Section 1.2, Angle Relationships and Similar Triangles. First thing we'll talk about in this section is vertical angles. Vertical angles are angles that are opposite of each other, having equal measure. So you have two lines that intersect, and when you have two lines that intersect, they make a set of four angles. Well, the angles that are opposite each other through the vertex are called vertical angles, and vertical angles are equal. And we can use this property to find the measure of the vertical angles. We can actually use this property to find the measure of all the angles. But in this problem, it says find the measure of each marked angle. So we know that these two angles are vertical angles, and therefore they are equal to each other. And that's what we're going to do. We're going to set them equal to each other. So you have 11x minus 37 is equal to 7x plus 27. And then from here we'll just do some algebra, and so we'll subtract 7 from both sides, and we'll have 4x minus 37 is equal to 27, and then we'll add 37 to both sides, and we will get 64. And then if we divide both sides by 4, that's going to give us x is equal to 16. Now, like we've talked about before, this is not the answer, because this is just telling us what x is. In order to find the measure of each marked angle, we're going to have to go in and plug 16 into these algebraic expressions. So we'll have 7 times 16 plus 27, and put that in our calculator. 7 times 16 plus 27, and that's going to be 139. Now, since we know the property that vertical angles are equal to each other, we automatically know that this one's going to be 139 as well. But you can plug 16 in for x and do the math and check your work and make sure you do come up with 139. So that's vertical angles. Okay, so what happens when we have parallel lines and they're cut by another line called a transversal? Well, like I said, when you have two lines that intersect, it makes a set of four angles. Well, when you have two parallel lines, you have two sets of four angles, and these angles are related. And here at the bottom are all the properties for these angle relationships. So corresponding angles have the same measure. So what is a corresponding angle? A corresponding angles are angles that are in the same position but in a different set. Now again, you have to have parallel lines cut by a transversal to have these properties, so keep that in mind. So corresponding angles is like angle 1 and angle 5 because they're in the same position but in a different set of angles made by these parallels cut by the transversal. And then 2 and 6 as well are in the same position, 3 and 7, 4 and 8. So those are corresponding angles. And then you have alternate interior angles have the same measure as well. Alternate interior angles. So interior means that they have to be on the inside of the parallel lines, and alternate means they have to be across the transversal. So for example, 3 and 6 are alternate interior, and 4 and 5 are alternate interior. So 3 and 6 are equal measure, and 4 and 5 are equal measure. Alternate exterior means that they're going to be on the outside of the parallel lines. So alternate means they're going to be across the transversal. So for, again, 1 and 8 are going to be alternate exterior, and they are the same measure. And 2 and 7 are alternate exterior, and they're the same measure as well. Then you have adjacent angles that are supplementary. Adjacent just means next to. So adjacent angles would be like 1 and 2, and they are supplementary because they make up this 180 straight degree angle, make up a straight line, so it's 180 degrees. So 1 and 2 are adjacent, 1 and 3 are adjacent, 2 and 4 are adjacent. Anything that makes up a straight line, 3 and 4 are adjacent. And then you have interior angles on the same side of the transversal are supplementary as well. So in other words, interior angles on the same side, for example 3 and 5, those are interior angles and they are supplementary, so they're going to equal 180 as well. 4 and 6, same thing, 180 degrees. And then of course you already know about the vertical angles that are equal. So we can take these properties and we can find the measures of different angles if you have parallels cut by a transversal. So find the measure of each marked angle. Well, we know that these two angles here, 2x plus 61 and 9x minus 135, are vertical angles. So what we can do is we can take these two angles like we did earlier and we can set them equal to each other. So we have 2x plus 61 is equal to 9x minus 135. And then when we do the algebra, I'm going to minus 2x from both sides, so we'll have 61 is equal to 7x minus 135. And then I'm going to add 135 to both sides, and we'll have 196 is equal to 7x. And then if we divide by 7, we'll have x is equal to 28. Again, this is not the answer. We've got to plug 28 in for all these x's. So let's do 2 times 28 plus 61. 2 times 28 plus 61 in the calculator is going to be 117. So we know that this angle is 117 degrees. Now let's use our properties. You can plug 28 in for all these x's and figure out what these angles are, or you can use your properties and get them really quickly. And you need to know these properties for on down the road. So since these two angles, the 2x plus 61 and the 9x minus 135 are vertical, we know that this one's going to be 117 as well. We know that corresponding angles, 9x minus 135 and 6x minus 51, corresponding angles are congruent, are the same. So we know that this one's 117 as well. And then these two angles are adjacent, so that means that they have to equal 180. So what we can do is we can take 180 minus 117 and get that angle, 180 minus 117, and that's going to give us 63 degrees. So if you know those properties, you can find the measures of these angles really quickly without having to actually plug in and do the algebraic expression. Alright, angles of a triangle. This is another property that you need to know. The sum of the measures of the angles of any triangle is 180 degrees. The measure of two angles of a triangle are given. Find the measure of the third angle. Well, we have options here. You can, in your calculator, do 180 minus 104 minus 29 and get the answer that way. 180 minus 104 minus 29, and that's going to be 47 degrees. So your other angle is 47 degrees. The other option is to take the two angles that are given and add them together. So you have 104 plus 29, and that's going to be 133. So we'll put an or here. And then you can do your 180 minus 133 if you want to, and that's still going to give you 47 degrees. Either way. Alright, so with degrees and minutes, to me the easiest way to do that is to add the two like we did earlier in the other section. So you have 136 degrees, 50 minutes, plus 41 degrees and 38 minutes. So if we add these two together, we have 50 plus 38. Add your minutes together and we're going to get 88, and then add your degrees together, 136 plus 41, and that's going to be 177 degrees. Now, like we talked about earlier, we do have an extra degree. We do have a whole degree in these minutes, so because it goes over 60. So what we're going to do is we're going to take a degree and add it here and do 88 minus 60 because we took out that degree, and we'll have 28 minutes left. So now what we need to do, that's just these two angles added together. So to find the third angle, what we need to do is we need to do 180 degrees, which is what the addition of all the angles in a triangle is, and subtract the other two angles from it. Subtract the other two angles from it. That should be a minute. Alright, so again, like we learned in the previous section, you can't take 28 from 0, so we're going to have to borrow. So this is going to turn into 179 degrees, and this is going to turn into 60 minutes. And so now that we can do that subtraction, so 60 minus 28 is going to give us 32 minutes. And then, of course, 179 minus 178 is going to be 1 degree. So we have 1 degree and 32 minutes. That's how big the other angle is. Okay, so let's look at this one. We know that the sum of the measure of all three of these angles has to be 180 degrees. So that's what we'll do. We'll take each angle and add them together. Alright, and so we'll do some algebra. So 2x plus 1x plus a half of x is going to be 3.5x. And then you have negative 120 and negative 30 and 15. And that's going to be a negative 135 is equal to 180. I think I'm going to go ahead and turn this into an improper fraction. You have your calculators, so it doesn't matter how you do this, but 7/2 x is equal to, let's add 135 to both sides. And so we'll have 315. Now, to get x, you have to know how to get rid of a fractional coefficient. You can use your calculator and do 315 divided by 7/2, or you can multiply by the reciprocal, which is what I'm going to do. So we'll have 315 times 2 divided by 7, that's going to be 90. So x is equal to 90. And again, this is not your answer. That's just what x is. So now what we have to do is we have to plug x, or to plug 90 in for this x. And do the math. So we'll have 2 times 90 minus 120, and that's going to give us 60. So this angle is 60 degrees, and then for this x, if we do 90 minus 30, that's going to give us 60 degrees as well. And if you know anything about a triangle, this would be an equal angular triangle, so it's going to be another 60 degrees here. Alright, so what I'd like you to do is I'd like you to pause the recording and try these problems. If you need help, go back and look in the video, look in your book, look in your notes, and bring these into class and we'll discuss them. Alright, the next thing we're going to talk about is classifying triangles according to their angle measure. So acute triangles have 3 acute angles. Remember, acute is less than 90 degrees, 0 to 90, 0 but less than 90, 0 to less than 90. Right triangles, a right triangle has only one right angle and 2 other acute angles. And then obtuse triangles have only one obtuse angle, and remember, obtuse is greater than 90 degrees up to 180. Has only one obtuse angle and 2 other acute angles. So that's how you would classify a triangle according to the angle measures. You're going to look to see if it's acute, right, or obtuse. Now, to classify a triangle according to the sides. Scaling means that no sides are the same. Scaling means that no sides are the same measure. Isosceles means that you have 2 sides that are the same. An equilateral means that all sides are the same. And you have to understand that the sides and the angles are related, and we'll talk about that in just a minute as well. Okay, so classify each triangle by side length and angle measure. So if I look at these tick marks, we learned this in geometry, these are congruent marks. And since all sides have just one congruent mark, that means that all sides are congruent. So that means that this triangle, according to the sides, is equilateral. And since all sides are equal, we also know that all angles are equal, so this is going to be equal angular as well. Alright, so we have equilateral, that's going to be our sides. And then acute, right, and obtuse, so since it's equal angular, they have to be 60. All of these are going to be 60 degrees. And so this is going to be an acute triangle. Alright, so this one, you have 2 congruent marks here and 1 congruent mark for each one of these. So that means that these 2 sides are the same, but this one's different. So remember, 2 sides that are the same is going to be isosceles. And then also, if this going through the center of the triangle, if the two sides opposite, and again this is from geometry, if two sides are opposite or the same, then the opposite angles are also the same. So what we have here is we have two acute angles. So this is going to be acute as well. Okay, so here each side has a different amount of congruent marks. That means that this is going to be scalene. But this angle is obtuse, so we have an obtuse triangle. Now, this box here, again, this is from geometry, this box means that you have a right angle, so we know that it's going to be a right triangle, and these two sides are congruent. They're both length of 2 units. So what we have here is an isosceles right triangle. Alright, so that's how you classify a triangle according to length and angle. Alright, similar triangles, this is your similarity symbol. So similar triangles, you'll see this little symbol, are exactly the same shape but different sizes. Same shape but different sizes. So the corresponding angles are congruent. So if the shapes are turned to where they're the same position, then your corresponding angles are congruent. So for example, if we had triangle A, B, C and triangle D, E, F. Alright, so we know that since these two triangles are similar, angle A is similar or congruent to angle D, and that would be your congruent symbol. That just means that they're the same angle, so they would both be 90 degrees. Angle B is congruent to angle E, and angle C is congruent to angle F. So corresponding angles are congruent and corresponding side lengths are not congruent but proportional. And so in this particular problem it says find the missing sides, so what we can do is we can set up a proportion. So what I like to do is, again, remember corresponding side lengths are proportions, so we're going to set up a proportion. What I like to do is I like to put the sides proportional, because that's what it says. So we're going to have something like 14 is to 21, because they're in the same position. 14 is to 21, as is, that's going to be your equals. 12 is to x. Now you have to be careful how you set up these proportions. They have to be set up correctly. So for example, if I put 14 on the top here, 14 is to 21, so the little triangle is to the big triangle, as is, little triangle is to big triangle, and that has to be set up that way. So now that I have a proportion, I can cross multiply, so I'm going to get 14x is equal to 12 times 21 is going to be 252, and so x, divide both sides by 14, is going to be 18, so x is equal to 18. Now, again, just make sure that you have these proportions set up correctly, alright? And the triangles have to be arranged to where they are positioned the same. So this would be another example. You have two triangles. You have the smaller triangle and you have the bigger triangle. And it says the triangles are similar, so that's given. Find the value of x given that A is 12, so this one's 12. B is 15, so this one's 15. C is 6. D is 4. And E is 5. So we can set up a proportion to find x. So we know that we need to use these two sides because that's the one that's involved with x. So let's do 6 is to x as is. Now I did the little triangle on top. So let's do 4 is to 12. Again, I have to use this side, so I have to use the 6 and the x. So I did little triangle over big triangle on the left side, and I did little triangle on the over the big triangle on the right hand side as well. From here we're going to cross multiply, so we'll do 6 times 12, which is going to be 72, is equal to 4x, and then divide both sides by 4, and we get 18 again. So x is equal to 18. For this problem, it tells us that our triangles are similar, and we're looking for the angle B. So we're trying to figure out what this angle is going to be right here. And it tells us that angle A is 10 degrees, and it tells us that angle E is 61 degrees. Well, because of these congruent marks, I know that if angle A is 10 degrees, angle D has to be 10 degrees. So let's put these triangles, let's draw these triangles to where corresponding parts match. So we have A, B, C. So when I set another triangle up, I know that since A is congruent to D, D has to be here. I also know that C is C. I mean, it's the same angle here. And so E is here. So since A is 10 degrees, these two are congruent, so this is 10 and this is 10. And it also tells us that E is 61. Well, look, E and B are corresponding angles, so that means that they're congruent. So angle B has to be 61 degrees as well. So angle B is equal to 61 degrees because of corresponding angles of similar triangles are equal. Okay, so for this one, what we have is the triangles are similar, so you have a big triangle and you have a little triangle. And it says find the value of x given that A is 20, so this side is, or this portion of a side is 20, and B is 60, and C is 44. Alright, so let's set up our proportion. I know that I have to have x involved, so I'm going to do little triangle x over big triangle corresponding parts 44. These are already set up to where their corresponding parts are arranged the same. So since I have little triangle on top, I have to have little triangle on top over here as well. So we're going to have 60 is to this whole entire base side. So 60 plus 20 is going to be 80. And so if we cross multiply, we're going to get 80x is equal to whatever 60 times 44 is. That's going to be 2,640. And then if we divide both sides by 80, we're going to get x is equal to 33. So x is equal to 33. Alright, let's try a word problem or two. See if we can draw our own diagrams. A forest fire lookout tower casts a shadow of 180 feet. So we have a forest fire tower that casts a shadow of 180 feet. Alright, and we can make this into a right triangle if we need to. And then it says at the same time that the shadow of a 9-foot truck, so we have a little truck here, casts the shadow of 15 feet. So that's 9. And then it says find the height of the tower. So we're looking for this. Alright, so we have similar triangles. So since we have similar triangles, what we're going to do, we have right triangles here, we know that. What we're going to do is we're going to set up a proportion, so we can say 9 is to x, as is 15 is to 180. Now something to notice is that our units are all in feet, so that's a good thing. We've got to have the same units before we can set up a proportion. So I did 9 is to x. If you want to do x is to 9, just make sure you have 180 is to 15. That's fine. So if we cross multiply, we're going to get 15x is equal to 1,620. And then if we divide both sides by 15, we have 108. So x is equal to 108. So the height of the tower is 108 feet. Okay, a triangle drawn on a map has side lengths of 9 centimeters, 10 centimeters, and 15 centimeters. So let's draw a triangle that has that. So we have a 9 centimeter, 10 centimeter, and 15 centimeter. Alright. The shortest of the corresponding real-life distance is 134 meters. So let's do another triangle. Similar triangle, kind of, sort of. The shortest distance, okay, so the shortest distance on the scale is 9, so the shortest distance is going to be, its corresponding part is going to be 134 meters. Find the longest. So the longest on the scale is 15, so this is the one that we're looking for. Now again, we have centimeters on our scale, but we have meters on real life. So what we need to do is we need to do a unit conversion. So if you remember, King Henry died Monday drinking chocolate milk. This is your metric conversion, and we have centimeters and meters, so we know that there are 2 decimal place values between meters and centimeters. So what I need to do is I'm going to change my larger unit to my smaller unit by moving my decimal. So what I have is 134.00. I'm going to move my decimal 2 places, so I'm going to have 1340, or 13,400 centimeters. So now that I have my units the same, I can set up a proportion. I can do 9 centimeters is to 13,400 centimeters, as is 15 centimeters is to x. And I can do my proportion now. So I have 9x is to, or is equal to, let's do 15 times 13,400. So we have 201,000, and then if we divide by 9, we have x is equal to 22,333 and 0.3, it repeats. Alright, so now what I'm doing though is I'm looking for the real life measurement. And I don't want it in centimeters, I want it in meters because that's what was given. So since I moved the decimal 2 places to the right to do the problem, I need to move the decimal back 2 places to the left. So that's going to be x is equal to 223.3 repeating meters, not centimeters, meters. So x is going to be 223.3 repeating meters. Alright, so what I would like you to do is I'd like you to try these problems on page 16 through 19. If you have problems, troubles, look back in the video, look in your book, look in your notes, and bring them into class and we will discuss them.